Humans all over the world are changing landscapes at an unprecedented rate. Bats, for example, have to change their behaviour in order to survive. So they either stay put at risk going extinct, or they adapt their behaviour and move into more human-dominated landscapes. Where we see an infection be transmitted from one animal species and circulating in it into a new animal species, that transmission event is what we call a spillover.
In recent years, a number of studies discovered and confirmed the association between spillover of disease from wildlife to other animals and humans and environmental change. In our study, we bring into that conversation a deep understanding of the ecology and behaviours of the animals that are transmitting the disease. It allows us to look for interventions to help mitigate and prevent spillover.
One of the key events that initiated this research was the opportunity for an experienced ecologist to be involved in Hendra virus spillovers on horse property, so to be involved with veterinarian and public health officials, and to make those connections from that deep understanding of flying fox ecology that there was something unusual going on there. From that, generate hypotheses, gather the data sets to test those hypotheses over 25 years.
And those data sets have come from a number of sources. So we've worked with a range of people, from government departments and local governments who monitor the number of flying foxes at individual roosts, to wildlife rehabilitation practitioners who document the condition of the animals through time, to beekeepers, professional apiarists who help us monitor nectar flow. In our study, we discovered that the behavioural responses to periods of acute nutritional stress, instead of reverting back when conditions improved, they have continued to display those behaviours. And that behavioural change is what has led to Hendra virus spillover risk being increased. One of the most important findings of this research has been to identify the process that's protective against spillover. And that is a rich pulse of native flowering that is sufficient to draw more than 100,000 flying foxes to an individual roost. We can identify a specific intervention that will increase the reliability of those winter food sources being available and therefore be protective of spillover.
And so we're trying to use that ecological response. If we were wanting to prevent pandemics, looking at human transmission, developing vaccines and therapeutics is very important, but we really believe that we need to invest in preventing the spillover in the first place, and so that's what this research is all about.